with yesterday?
Oh, I wrote it all down.
My hand was hurting.
Yeah, my hand was like cramping up over there.
I was extremely busy though with these bikes ruining my life, and I didn't have time to really process them all.
Sorry. Well, it's a good thing we're going over it
Oh,
today.
I didn't process any of it.
That's
Yeah,
okay.
no, I just wrote it down. I just.
That's
I think it's a
okay.
stretchy.
That is.
I'm gonna touch it. It's probably covered in passes now.
Sock for your hair.
Okay.
It's a scrunchie. I would make it. I just use a sock.
Are we ready?
No.
So the first thing we're going to do before we actually find them is we're going to talk about what extreme and relative extrema are. Relative and absolute extrema are. Hopefully you already know. So if I have a graph, such as this, our relative extrema are all the hills and the valleys that are occurring. So this would be a relative maximum because it's a hill. This would be a relative minimum because it's a valley. The relative are also called the local extrema because they're not necessarily the highest or the lowest points on the entire graph, but they are the highest or the lowest for that area that they're in. So if this is where my graph stopped, then this would be my absolute minimum, and this would be my absolute maximum. So our absolute are the highest or lowest on the entire graph on the domain that we're looking at. Okay, so it also goes by the domain. Relative or local are just the hills and valleys. Absolute are the highest or lowest on the entire graph. Hopefully you already know this somewhere in your brain because I know we've gone over it. So I just wanted to remind you necessarily what it was. When we're talking about our relative extrema, because that's what we try to abbreviate this into, we identify them based off of their x and their y value. So I'm looking for the extrema point, not just the x value or the y value. I would like both. So there are several examples on the notes of just looking at a graph and identifying our extrema. I don't think we need to go over that because I don't know, it's pretty self-explanatory to me.
I did have one question.
Yes.
On something kind of like that.
Okay.
So if your domain, like I'll use something simple like y equals x, if your domain is like from 0 to 1 but not including 0,
Then 0 cannot be a minimum.
then what would you put? Because the point
There
is
would be
obviously
no
there.
absolute because we could get infinitely close to 0, so I'd never be able to pinpoint one point. So his question comes from the last example on that first page. So it is y equals x squared. On the domain 0 to 2, so when we look at it, there's an open circle at 0, but a closed circle at 2, which means my absolute maximum would be 2, 4, right? Because that's the highest point on the graph. There technically would be no absolute minimum because I can get infinitely close to 0, which means I'm going to have infinitely low points, but I'm never going to reach one lowest point because there's no number that is directly next to 0. We can always get infinitely closer. We could say there's a relative, like if we were approximating, but it wouldn't be good enough. So this would have an absolute max.
So I don't get like why.
Okay, so tell me, what do you mean? We just have 2 what?
Like you have 0 and 2, but like why is 2 bad?
Because when I plug 2 in, 2 squared is 4. I just identified the XY pair. But there would be no absolute minimum here. Does that kind of make sense? Because if you tell me a number that's directly next to 0, like you think that's the closest you can get, we could just add another decimal place, and I got closer. We can always just keep doing that until there's an infinite number of decimal places, and then you can't really say that's the lowest number we could possibly have. So it's just like infinity. You can't tell me what the number is, so it doesn't technically work. That makes sense to everybody? Okay, so does it make sense how we have an absolute maximum here? But I don't have an absolute minimum, right? Because I can't include 0. So what is the number closest to 0 that I could use instead? Tell me a number. I would definitely not do 0.9, that's close to 1. But then 0.01 is actually closer, right? And then 0.001 is even closer than that. And then 0.0001 is even closer than that. So I could just keep adding zeros in front of that 1 until there's an infinite number of zeros there. But then I can just add one more and I'm a step closer. So there's no one number that's directly next to 0. So that's why there's no minimum here. That kind of makes sense? Okay. Corbin, put the book away. Amazes me I have to say that. Okay. If this had been a closed interval, so if I had a hard bracket on 0 and I was including it, then 0 would absolutely be a minimum here. But when it's open, you really have to look at that, and sometimes there is none that exist for that given domain. So hopefully another thing that was pretty easy for you was the extreme value theorem. And it just says that if my function f is continuous on a closed interval, there will be a minimum and a maximum on that interval. So that to me seems like common sense, because if it's continuous, I'm always going to have a highest point and a lowest point if it's closed. I don't really know why we need to talk about that, but we do. This only works, however, if it is a closed interval and if the function is continuous. So if you look in the notes, because some of you might have it up or you wrote them, I gave 3 examples. The first one was continuous. It looks something like that. On the interval a to b, so there had to be extrema in there. So there had to be a highest point and there had to be a lowest point. However, on my second example, is that function continuous? No. I have lots of removables in there, or holes in my graph. So extreme value theorem would not apply here. There might be a minimum and there might be a maximum still, but there isn't guaranteed to be any. It just might happen by chance. If it's asking, can you use extreme value theorem? You can't use it. So you would say, cannot use EVT here because it's not continuous.
If that dot was above the endpoints, would it be a max?
Technically, yes. It would be a maximum for the graph. So as I said, you can technically have one, but by EVT, you're not guaranteed to have one just because it's not continuous. So that's always the first thing you need to check when we're talking about extreme value theorem. I don't ask a whole lot about that, and that's usually not a topic on the AP test, at least not outright. So what we're actually going to do now, those are out of order, is finding these extremums, or the extreme values here. There are 2 types of extrema, as we already talked about. There is absolute and there is relative. For the most part, we are finding relative. Yes.
You do see that was like the only one that didn't okay.
Why it was or why it wasn't?
Why we could still use it, but it wasn't.
I identified a minimum and a maximum, but I said EVT doesn't apply. So it wasn't guaranteed to have one, but by chance it did have one. Yes. I don't know what we're saying now. Okay. So most of the time we are finding relative extrema here unless there's a closed interval or an interval given, in which case we can identify absolute. We assume for the most part that all functions go infinitely in the positive and the negative direction. So unless it's a very obvious curve, we can't guarantee there's an absolute unless we're given a specific interval to look at. Okay, so we're going to be doing it kind of 2 different ways, and on your homework you have to do it the 2 different ways. But there's, like, it's not overly difficult, it's just an extra step. So when we're talking about extrema, there are 3 points technically that are candidates that could potentially be those maximums or those minimums. The first candidate is where my derivative equals 0. And these are called our critical points. On the AP test, they are also mostly referred to as critical points, so you need to know what they're talking about there. So critical points are just simply where your derivative equals 0 at. If that's not where my minimum or maximum is at, then it could be at the endpoints of the domain that I'm looking at. Okay, so this is where the absolute comes in. If I'm given endpoints for my domain, I have to use them. And the third one is where my derivative is undefined. That doesn't happen very often, but they are potentially minimums or maximums there. On all of these examples, we're going to be testing all three of these. And then from those, we're going to identify the x values that give us the highest and the lowest points.
So what about stationary?
Okay, so stationary points are any of your minimums or maximums that are not critical points. So any of these that I find that are not critical points are called your stationary points.
Give an example.
We'll do it in the thing. There's some examples that have them, or at least one that has it. So let's go ahead and jump right into an example because that's the easiest way to do these. Let's start with the function f of x equals, x cubed minus 2x plus 4. I am going out of order because I think I want to start easier and then work toward the little more complicated ones. I have to test all three candidates, right? What's my first candidate or set of points that could potentially be minimums or maximums? Points where the derivative equals 0. First, I have to find what my derivative is. So what is the derivative of this function?
X squared minus
3x squared minus 2. Right? Power rule. Once I have the derivative, I need to set that equal to 0. What's going to be the easiest way to find the zeros for that? Don't I just set it equal to 0 and solve? Yeah. So then I'd add the 2 across and I get 2 equals 3x squared. Divide each side by 3. I get 2/3 equals x squared. Square root both sides. And I get x equals positive square root of 2 over 3 and negative square root of 2 over 3. So I have two potential extrema right there. Once I have identified those, I go ahead and I move on to the second possible candidate. So what are the next points I have to check for? What's number 2? Endpoints. Was I given an interval here?
No.
No. So endpoints we don't need to check. And then 3 is what?
That's not.
Is there anything that would be a discontinuity here? No. No, it's a polynomial which is continuous across negative infinity to infinity. Okay, so again, there are none here as well, which means my extrema, if they exist, can only be those. To identify which ones are or are not extrema, I like to do a number line because it's a really good way of checking. So on this number line, I'm going to put my potential zeros. I'm going to plug in numbers around them, and then I'm going to plug them in as well. So I'm going to start by plugging them into the original function. So we're going to take negative square root of 2/3 and plug it in for x. When I do that, I get 5.089 as my y value. When I plug in positive square root of 2/3, I get 2.911. As I'm looking at it, this is the higher y value, so I'm assuming this is the maximum. And this is the lower y value, so I'm assuming this is the minimum. But I still have to check. I need to verify that those are, in fact, turning points on my graph. So I need to plug in a number that's less than the square root of 2/3, a number between negative square root of 2/3 and positive square root of 2/3, and a number bigger than the positive square root of 2/3. When we do, we get that this is a positive, this is gonna be negative, and this is gonna be positive, which means that it went up and then went down when I hit this point, and this one went down and then went up, which verifies this is a maximum and this is a minimum. So then I could say that my maximum is this point and my minimum is this point.
How do you know it?
I plugged numbers in. So I plugged in a number that was less than the negative square root of 2/3, say like -5, I would get a positive answer in the original function. Then I plugged in 0. That didn't work out, did it? It's fine, we'll go back to it. I just made those up. Plug in a number, you get an answer here, and then plug in another number and you get an answer here, and that verifies that we do in fact have maximums and minimums. I'll look at that one later. Okay,
It's probably fine, but I just.
no, you're fine. I might have plugged them in opposite, that's fine. I'll look at it later. But this is the theory of how it goes. If I had had endpoints, I would have had to test those on the outside as well. And then those would have been where I stopped. Okay, so let's go ahead and do another one because I think we're all thoroughly confused.
That's everything.
Doesn't matter what you do.
You're
It's
always
okay. I'm gonna have
confused.
to go back and watch the first one.
Okay, so the next one I would like to test. Do that one. One over x squared minus 1. What's the first thing I need to do? Derivative. Do I want to take the derivative of it the way it is right now, or do I want to change it into a chain rule problem? I would probably want to do chain rule because I hate quotient rule. So this is the same as x squared minus 1 to the negative 1 power. And then I would use chain rule to take the derivative of that. So when we take the derivative, we get negative of x squared minus 1 to the negative 2 times what? 2x. So when I rewrite this, I get negative 2x over x squared minus 1 squared. Right? Yeah. Anybody majorly confused with that?
That really started sucking whenever X went to the bottom.
It did. It really, really did. Okay. So for the first step, I want to find where my derivative equals 0, correct? Do I need to consider this entire fraction or just a part of it?
The C at the bottom is also 0 and the top is 0.
Correct. So I'm only considering the top. And then once I figure out what makes my top go to 0, I'll plug it in to make sure it also doesn't make my denominator equal 0. Because if it does, I can't use it.
But if it does, can you just use it?
Yes. We're getting there. Okay. So what would make my numerator go to 0? 0. If I plug 0 back into the denominator, do I get 0? No. So then for my first part, my only candidate so far is x equals 0. What do I look at next? Endpoints. Do I have any endpoints here? No. No endpoints. Because I was not given an interval to consider it on. And then part number 3 is what makes my derivative not exist, right? Which means it has an asymptote or a discontinuity happening. Clearly, since I have a denominator, I need to consider an asymptote. So what would make that denominator equal 0? Or 1 and negative 1, because negative 1 squared is 1, 1 minus 1 is 0, positive 1 squared is 1, minus 1 is 0. So I have 3 potentials here. I need to check to see which ones do or don't actually work. So I go ahead and I can do the number line because that's what I like to do. You could also just plug them in and then verify afterwards. When we're plugging them in, we're plugging them back into the original function. So this one up here. Okay? So when I plug negative 1 back into that original function, so we're going to plug it into this one, what's going to happen? doesn't exist, which means it cannot be one of my extrema. What happens when I plug positive 1 back into that original function? Same thing, I'm gonna get a 0 in the denominator, which means it doesn't exist, which means it cannot potentially be one of my extrema. Since I'm down to 1 possible, I will either have a maximum or a minimum. I will not have both. So I take the 0 and I plug it back into that original function, and I get what? I get -1, which means 0, -1 is either a maximum or a minimum. To test this, I need to plug in numbers on either side. So when I do that, I get a positive on the left and a negative on the right, which means going into 0, it was going up, and coming out of 0, it was going down, which makes 0 what? A maximum. So then my max is a 0, -1.
You can't have a derivative of 0 that's not extrema, right? Like on x cubed, 0 wouldn't be extrema.
There are exceptions to every rule.
That's hard.
And sometimes we get something that seems like it could be an extrema that's actually not, which is why we do the table. Because you could get positive, and then a negative, which indicates that even though it looked like an extrema, it's not actually an extrema, which is why we always like to check around them. However, I don't think on your homework that's going to happen.
All right, I'm ready for a nap.
No. Another example. 'Cause I know how much you guys are loving these.
I need a nap.
The next example I would like to do is the first one in your notes. And it is f of x equals e to the -x. And it's on the interval -1 to 1.
Yeah.
That was wonderful.
Oh, I need a nap. Let me just sit real quick. What would you do if we didn't sleep?
Well, it's more what you'd be doing to yourself, because I guarantee passing would be a lot harder.
Yeah, I'm barely bad. Well, I have a C plus.
Okay, what's the first thing I need to do? Take the what is the derivative, Erin?
I don't know.
I'll have it wrote down.
Okay, how do I take the derivative of e to the x?
It's the same thing, so you have a negative x.
So e to the x times the derivative of x, right? Or whatever is in my x place.
See,
So my derivative is going to be e to the -x times the derivative of -x, which is -1. So then this just becomes negative e to the -x. That is my derivative. That was not a trick question.
Is that the same thing as -1 over e to the x?
Yes, it's exactly the same. Okay, so then for step 1, we need to look for what value or values is going to make this derivative equal 0. Liam did point out that this is the same as -1 over e to the x. Is there anything I can plug in for x that's going to make that equal 0? Only way to get a 0 in a fraction is if the numerator goes to 0, and it's a constant, so that's never going to happen. So there are no possible candidates as a critical point. None at all. Which means I move to step 2. What do I have to test after I test my critical points?
Your endpoint, negative.
My endpoint, so -1 and 1. So for step 2, I'm just going to take that -1 and that +1, and I'm going to plug them into the original function. Anybody know what we're going to get?
You never take the
I have it
log of
wrote
0.
down.
Can you ever take the log of 0? Natural log or just regular log? Are we talking base 10 or base something else?
Yeah, I don't. Just anything.
Okay, so when I plug in -1, I just go ahead and I get e. It's just how it works out. And when I plug in +1, I get 1 over e. Are those my guaranteed maximums and minimums? No, why not? I still have to do step 3, which is what?
Does not exist.
Does not exist.
Where my derivative doesn't exist. Is there anywhere that it doesn't exist on that interval?
How do we tell?
I don't think it's
This is my derivative. I would have to make that denominator equal 0. There's nothing that's going to make that denominator equal 0 on my interval. So 3, there are none. Which means my only potentials are e and 1 over e. Which one of those is bigger? E, so that's going to be our maximum. Which one of those is smaller? Which makes that our minimum. We would verify by doing a number line and plugging in numbers around them.
Okay, how would you put a number in?
For us,
Well, e is 2.7 something rather. So you would plug in something around that.
3 years.
so from number 3, you said,
There's nothing that makes that undefined.
so it exists for all.
So yes, it is not discontinuous anywhere. Okay, so I'm actually going to stop here because I don't want to confuse you even more.
I've already.
It is possible to find your extrema using a calculator as well. So you would just plug it into your calculator, obviously, and you can actually, calculate your minimums and maximums based off of the calculator values that you have. But there are no calculator portions to things, so you need to know how to do it outside of the calculator as
Well,
well.
what the heck is
But it's a good way to check.
no cal?
Okay, your homework is on Canvas. It's only 8 questions. The first half are relative extrema, which means there are no endpoints to test. The second half are absolute, which means there could potentially be endpoints to test.
Also, where the heck's Ethan? He's got
Yeah,
rid
where is it?
He is online.
Why?
of- What the heck?
What the? Is there basketball still?
Is he coming back?
He will be coming back after the semester ends.
Why?
It's funny actually because he's online right now. So say hi.
I will go.
Wait, can he hear?
Yeah.
Ethan, I didn't know you were in basketball.
So Lauren, I heard that apparently